Hello children, welcome back again. So in this particular video, we are going to learn the continuation of Arrhenius theory regarding the neutralization reaction. Which reaction? Neutralization reaction. So according to Arrhenius, the theory names also regarding the neutralization concept. We'll see what is that. Generally, you know what is neutralization? Yeah, the previous videos we already told the concept regarding the particular neutralization and the particular concept regarding when an acid and base react together to give a salt and water. Yes. So in that particular concept, based upon that only, Arrhenius, he gave in his own theory that about neutralization reaction. We'll see what is that. Okay. Generally, what is neutralization? When an acid and base reacts, it gives rise to salt and water, and that is known as neutralization. And here it is regarding Arrhenius theory regarding neutralization reaction. Okay, we will see what's that. Here we go, we will start the session. Okay, when an acid reacts with a particular required amount of the base, just wait. Okay, see, when an acid reacts with the required amount of base, both will lose their characteristics. Very important. Both will lose their characteristics properties, resulting in a neutral solution. So when an acid combines with base, what happens? It gives rise to salt and water. Yes, salt and water. So these two are completely different with that of acid and base, right? So what is going on here? An acid is reacting with the certain amount of base, and what happens? They both, the acid and base respectively, they are losing their particular characteristic property, because acid is having one particular property, children. You know properties of acids, right? Yes. Sour in taste, corrosive in nature. Yeah, very. We have many characteristics regarding the particular properties of acids. Yes, yes. Okay. Regarding bases also we have. Bases are slippery to touch, bitter to taste, and also corrosive. Some bases are also corrosive, and pH value is greater than 7. All these such properties, they have different characteristic property regarding bases and acids. But what happened here? Acids and bases, what is going on? They are reacting and they are losing their characteristic property, resulting in a which solution? Neutral solution. Which solution, children? Neutral solution, resulting in a neutral solution. What is neutral solution over here? Salt and water. Okay, salt and water giving rise to a neutral solution. What is that neutral solution? Salt and water. So in that case, acid and base reacting to give salt and water, and that reaction is known as neutralization reaction. Okay, so here they both are reacting together and they are losing their definite characteristic property to give rise to a neutral solution. Okay, so that is named as what? That is known as neutralization reaction. Okay, here we go with the according to Arrhenius. According to Arrhenius, neutralization is a reaction in which H plus ions of the acids combine with the OH minus ions of the base to give undissociated water. To give rise to undissociated water. So according to Arrhenius also same, the concept is regarding that only. But here they gave the word acid and base. Here it is representation of H plus ions and OH minus ions of acids and bases respectively. That's it. Okay. So this is what we know earlier. But according to Arrhenius, what is telling? Neutralization is something, a reaction in which H plus ions of the acids combine with OH minus ions of a base, giving rise to a undissociated water. Undissociated water is called as neutralization reaction. Here we go with the equation, children. H plus in aqueous solution, which means what? H plus in aqueous means, in aqueous solution, you know, the acid will give rise to, dissociates into hydrogen ion. Yes, and OH minus in aqueous solution, which means it is a hydroxyl ion, gives rise to water molecule, which is undissociated molecule. Okay, I will write here the words. H plus means, I will write down, children, hydrogen ion. Okay, OH minus means hydroxyl ion, hydroxyl XYL, okay, HYDROXYL ion, okay. So both of them in aqueous solution. AQ means, I'll let here. AQ is given in the bracket, that is nothing but aqueous solution, okay. Yeah. So they both react together, gives rise to undissociated water molecule, okay. Did you get that point? H plus OH minus gives rise to H2O. 2H from here and 1O from here. Clear? This is all about the neutralization reaction name according to Arrhenius theory. Okay, it gives rise to which water, children? Undissociated water. Okay, now clear? Now, examples of acids and as well as bases regarding this particular neutralization reaction. Okay, first example, acids neutralize bases to form salt and water. We know that already. Okay, base and acid reacting upon to gives rise to salt and water, and the names of the examples we already know, but once again we revise. Okay, okay, here the base, first one is base given, no? The base is NaOH and CO taken, and acid is HCl and H2SO4. Salt is NaCl and CSO4, and water respectively is H2O and H2O. We'll let the names of this. What is NaOH? Sodium hydroxide, very good. Sodium hydroxide. Okay, I'll write somewhat close. Sodium hydroxide. Okay, when sodium hydroxide reacts with what is HCl? Very good. Hydrochloric acid, also called as hydrogen chloride. Very good. Hydrochloric acid. It gives rise to salt and water. What is salt over here? Sodium chloride. Very good. Sodium chloride and H2O, which means it is a water, undissociated water. Okay. Now, this is a neutralization reaction. Clear? What is NaOH? Sodium hydroxide, HCl, HCl, hydrogen chloride, or also known as hydrochloric acid, gives rise to NaCl, which means it is a sodium chloride, and also it is a giving rise to water. So these two are named as neutral solution. Okay, I'll let the heading over here for you. So acid and base gives rise to a salt and water. What is this? Neutral solution. So Arrhenius named like this. Okay, H plus of acid and OH minus of base reacting together to gives rise to salt, and also with the these ions, no, so he gave like this H2, which means a undissociated water. Okay, salt is also present. Okay, but he highlighted the concept of ions, no, so that's the reason I written here like this. Okay, yeah. So the first example is sodium hydroxide plus hydrogen chloride or hydrochloric acid gives rise to sodium chloride plus water. Okay, the equation number 1 is like this: NaOH plus HCl gives rise to NaCl plus H2O. Okay, clear now? Now the second example, what is that CO? What is named as CO? The name, the molecular name, the formula is given. What is the name of that? Copper oxide. What is this? Copper, in the bracket 2 we'll write oxide. Okay, yeah. Now H2SO4, it is sulfuric acid. Sulfuric acid. So when copper oxide reacts with sulfuric acid, it gives rise to copper sulfate and water molecule. Very good. What is CSO4? CSO4 is named as copper sulfate and water molecule. Children, you know what copper sulfate is having which color in aqueous solution? You know, it is having blue color. Which color? Blue color. Okay, this is all about the examples of first acid neutralization to base to give rise to salt and water. Okay, they taken our sodium hydroxide and copper oxide as the base section, and hydrochloric acid and sulfuric acid as the acid section, and they're giving rise to salts such as sodium chloride and copper sulfate and regarding the water. Okay, these are examples for the first one as utilizing to base. Okay, now next let's see what's next. Yeah, same, but regarding here it is bases. Okay, regarding bases, neutralizing acids to form salt and water. So what's that? Let's see. Same equation, base plus acid gives rise to salt plus water. Okay, now the given equations to the names of this 2KOH. What is this? How to read that 2KOH? What is the meaning of 2 over here before K? Which means it is telling us 2 molecules of potassium hydroxide. 2 molecules of potassium hydroxide. So KOH is named as potassium hydroxide. Potassium hydroxide. So before 2 is there, no children? For that 2, what you have to read? We have to read as 2 molecules of potassium hydroxide. Into that, what we are adding? We are adding sulfuric acid. Which acid is this? Sulfuric acid. And for this 2 molecules of potassium hydroxide, if we add sulfuric acid, what happens? The respective salt and water is formed. What is salt formed here? K2SO4. What is K2SO4? K2SO4 is named as potassium sulfate. Potassium sulfate. Okay, potassium sulfate. And 2 molecules of water also. Water. I'll write here with green. We have to read as 2 molecules of, okay, H2O means water. Clear? Now 2KOH plus H2SO4 gives rise to K2SO4 plus 2H2O, which means 2 molecules of potassium hydroxide reacting with sulfuric acid gives rise to potassium sulfate and 2 molecules of water. This is the equation, how to write and how to represent with the keywords. Okay, how to read it, how to call it. Okay, clear now? Now second one, you know this too. NaOH plus HCl gives rise to NaCl plus water. The before example only. The first example is done before one. So sodium hydroxide plus hydrogen chloride or hydrochloric acid gives rise to sodium chloride and water respectively. This is the example for the bases neutralizing acid. Okay, the before one is acid neutralizing base, and just two examples of the particular neutralization reaction according to Arrhenius theory. Okay, hope you are clear with that, children. And here we go, end of the session, and watch the continuation of this particular theory in the next video. Okay, thank you.